Hey guys, so I've been using Leetcode for the past month now, and this platform has this really cool feature called Explore. So basically what Explore means is that you get monthly challenges like this. Right here we have September Leetcoding challenge, and in each of these challenges, this challenge is beginner friendly and available to both premium and non-premium users. It consists of 30 daily problems over the month of September. The problem is added here each day, and you have 24 hours to make a valid submission for it in order to be eligible for rewards. Now let's try the problem that came today. So I've been doing previous videos with random number generators and trying to solve problems randomly that I've never seen, so I thought I should give this one a try. Well, I did try the last 2 days problem, so I thought I'll record this one. Partition labels. So the string S of lowercase and English letters is given. We want to partition the string into as many parts as possible so that each letter appears in at most one part, and return a list of integers representing the size of these parts. So let's try to understand this problem first. We have S, A, B, so this thing, and the answer is 978. So why is that? So the question is asking us to partition the string in some way, and the output is actually the length of each partitions, right? So partition is AB, this is 9, this is 7, and this is 8. This is a partition so that each letter appears in at most one part. Okay, so each letter appears in one part. Okay, so now it makes sense. So we have A, B, and C are the distinct characters in this partition, and you can see that this is not available in any of these partitions. So you want to make sure that when you partition the string, the characters in that string in one partition cannot appear in another partition. So yeah, okay, a partition like this string seems to be appending these two partitions is incorrect because it splits S into less parts. So the question says here that you should return a list of integers representing the size of these parts. We want to partition the string into as many parts as possible. So that is why this is valid and this is not valid. And we should be, as it says here, we should be returning a list of integers representing the size of each partition, such that the number of partitions are more. I guess the first thing that I can think of looking at this problem is that we want to know the latest index that particular character exists. So if you take something like A here, we will actually copy this part down below. So okay, didn't copy. Right, so we have these two things. Now if we find A here, what's the last occurrence of A? If you go through the string, we find A here, we find A here. A is not existing anywhere farther than this. At this point, can we say that this is one partition? Maybe, but maybe not, right? Because there could be, let's look at B here. What's the last occurrence of B. You can see that the last occurrence of B is here, which is within A, so we still think that this could be a good partition. Let's take C. C happens before this A as well, so I think at this point you can say that this is a good partition. And then we go from here, right? D, E, F. So first we start with D. What's the last occurrence of D? So it's here. So can we take this partition actually? We don't know that yet. So let's take the next character, which is E. What's the last occurrence of E? So here you can see that it's E is happening after D. So now we think that this is a good partition. Well, we can't be sure yet. Let's take the next character. Let's take F. This itself is the last occurring character, so this is fine. E, we already found the last occurring character. G is itself. D is itself. And that is why we choose this as the good partition, like here. And let's try this. I think that's the idea for solving this problem. So basically we need to identify the last occurrence of a character, and then we need to do a single pass over the string and find the last occurrence of each of occurrence of the character, and we keep maximizing this last until we get to that character itself. So yeah, let's try and code this. So what do we need first for this? So we first need something like counts. Oh no, I think we'll call it last index, and we need 26 of these. Just need to be sure that, yeah, so the S will consist of lowercase English letters only, so we can say that 26 is the size of this. So this is actually for keeping track of the last index of each of the characters. I'm gonna type this because I will be needing this later. I equals 0, I less than n, I plus plus, last index of s dot character at I minus a plus plus. Not plus plus because we're not trying to keep count of this, we are actually trying to get the last index. So at the end of this loop we know that what is the last occurring index of each of these characters, right? So what's the next thing we need to do? Okay, we know that we need to go through the string, so let's do that. And let's get the first character and put it in a variable. So we have this character, right? Let's get the last of this partition, right? So this is ch dot character at last index of ch minus a and this will give us the last index of this character. So if we are at a, we get this index, right? What is this index now? It is 1 2 3 4 5 6 7 8 9. So that will be the 8th index because this is 0 based. So we want to loop until I plus 1, j less than or equal to last, j plus plus. So let's take the next index, right? So character at j and let's take the last index of that. And let's do one thing. Last equals math dot max of current last and last. So we'll keep going. So ultimately we need to return the list of integers that are the size of each partition, right? So we'll keep this thing, and we'll keep updating that. Out.add of last minus I plus 1, which will be the length. Need to be careful about I, setting I to I last plus 1, and we also need to be, I think, if you're doing that, then we probably shouldn't do this. I think we can return out, which would contain all the values. Let's try and run this code. Okay, it seems to have worked for this case. Let's try a different one. Let's try giving it a that has worked too. Let's try A, B, C, D, B. I think this should be giving us 1 and 4. Yeah, so I think it's working. So let's just try and submit the code. Yes, accepted. So I hope the explanation made sense. I'll be back again soon with another video. Thanks for watching.